All right, let's talk about quadratics. So a quadratic equation is any equation of the form of ax squared plus bx plus c equals 0. And that's where the a, b, and c are numbers, but the a cannot be equal to 0. So quadratic is anything in this form. So it'll have an x squared in it. By saying that a can't be 0, you're saying this part right here, this number can't be 0. So the a, the b, and the c are numbers, and they can be any numbers, but the a part can't be 0, because if it were 0, 0 times x squared, that would cancel out, and you just have bx plus c equals 0. That wouldn't be a quadratic, that would be a line, that would be a linear equation. So quadratics typically are representing anything that is launched into the air like this, like a ball that's thrown into the air, that leaves the ground here and comes back to the ground there. So it has this shape where this point's called a vertex. And this vertical line that goes here is a line of symmetry that cuts the graph into two equal parts. And so because of gravity, anything that's launched into the air is going to have this parabolic shape here. And it could be a really high parabola that's thin, or it could be thick, depending on the angle in which the ball or object is launched into the air. So a parabola could look like this. Let's draw this. So it could look like this, or it might look like this. Okay, so like somebody throwing a ball from the outfield, it might not get that high off the ground. It might almost be a line drive, but it would have that kind of a shape. So a quadratic is any equation in this form where a cannot be 0. And a parabola that has this shape like this, that opens downward like this, that means that the a value also is negative if it looks like this. So these points are x-intercepts on the graph. So if you have a graph, this is where the graph hits the x-axis. So if you solve a quadratic by factoring or by using the quadratic formula, the x-intercepts are solutions to that equation, and this is where those would land. I'll give you an example. Suppose that we had, let's start with something like this. So this is factored form for this. So when you solve this one, so we take each factor and set them equal to 0. This is called the zero product property. If you solve this one over here, x is 3, because 3 is the number that when you put it here, 3 minus 3 is 0. And when you solve this one over here, you get -4, because -4 is the number that when you put it in here, you get 0. So on this problem, you would have x-intercepts, think about this, of 3 and -4. So those would be your x-intercepts. Now, from this, what I could do is multiply those together. So I know that it hits here, but if I multiply those together like this, x times x is x squared, x times 4 is 4x, -3 times x is -3x, and -3 times 4 is -12. So if I multiply those together, here's what I end up with. This. So on this particular multiplication here, I get a positive value, which tells me that on this one, this is not opening downward, it's a smiley face. It's opening like this. So the question is, where's the vertex on this? So there's a bunch of ways I can do that, but probably the prevailing way, the prevailing method is x is equal to -b over 2 times a. So in this problem, the a is a 1. The a is a 1. The b is a 1 because that's 1x squared plus 1x, and then c is negative 12. So a is 1, b is 1, and c is negative 12. So if I want to find the vertex on this, I'm going to do the opposite of b over 2a. Well, up here, the b term is 1, so the opposite of b is negative 1. And it's over 2 times a, so 2 times 1. So it's pretty clear that the x value is negative 1/2. So negative 1/2. So negative 1/2, and then I'm going to go over, this is, oops, so this is my y-axis, and this is my x-axis. And I know that the line of symmetry is going to be right here at negative. This is the line of symmetry, negative 1/2. So the x value is negative 1/2. So what I'm going to do is take this and substitute it in here for x in both of those places to figure out what y is. So negative 1/2 squared plus negative 1/2 minus 12. Now, if I do the math on this, that's 1/4 because negative 1 times negative 1 is 1. 2 times 2 is 4. So minus 1/2 and minus 12. So anyway, find the least common denominator of 4. I got 1/4. This is minus 2/4. 2 goes into 4. 2 times negative 1 is negative 2. 1 goes into 4. 4 times negative 12 is negative 48. If I add all this together, that's negative 50. What is that? Negative 49 over 4. So negative 2 and negative 48 is negative 50. Negative 50 plus 1 is negative 49 over 4. And guys, that's going to be negative 12 and 1/4 just by changing that to a mixed number. 4 goes into there, negative 12 times, that's 48, 49. So negative 12 and 1/4. So that lets me know that down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 and 1/4, somewhere down here, this parabola is gonna look something like this. This is a pretty ugly drawing, but hopefully you get the idea that the vertex is down here. The vertex is at negative 1/2 and negative 49 over 4, which is about negative 12 and 1/4. So the vertex is down here, and this looks like this. So what I have shown you is a couple things, okay? So number one, I've shown you what a quadratic is by an equation. A quadratic is any equation that's in this form where a, b, and c are numbers, but a can't be 0. And I've shown you kind of the typical application of a quadratic is things being launched into the air due to gravity. Of course, if it's opening downward like this, the a value is negative. So it would look like this. So a ball or artillery, anything like that is going to have a parabolic shape. That's what that is. That's a parabola. And so the biggest application would probably be things launched into the air. This would be the launch point. This would be where it falls back to the ground. This would represent the ground here. The x-axis would. Your vertex is the highest point that it reaches, and that's called a vertex. And so you could have a really tall one like this. You could be like that, more shallow. That's the equation. And I've given you an example where we had x minus 3 times x plus 4. We multiplied that together and found this quadratic. And when I solved these by setting each factor equal to 0, I found out these were the x-intercepts. So this is the solution, or these are the solutions to this equation. So if you have this equation, then what I'm saying is 3 is a number that if you put 3 here and 3 there and you do the math, you'll get 0. And also negative 4 is a number that if you put negative 4 there and you do the math, you'll get 0. These are called the x-intercepts on the graph. So when I graphed this, I just plotted 3 and -4. I knew those were going to be the x-intercepts, and then I calculated the vertex. Now I drew this kind of crazy, but this is the line of symmetry about which if you cut this and folded the two halves, they would match up together. And I found out that the vertex here was this, x equals -1/2 and -49/4. You may have to go back through the video to see how I found the vertex, but I'm using this formula here. The vertex is the x value is equal to the opposite of b over 2a. And so I found out that it was -1/2 for x, and then I calculated the y value on that. So that's a little bit about quadratics. So in algebra, you spend a lot of time talking about lines, and lines are going to be in this form. Or at least that's one form you can write them in. And lines look like this. But now we're talking about quadratics. And quadratics are in this form. Ax squared plus bx plus c equals 0. Or you could even say y equals this. So you could write it this way. And these are going to either be a smiley face or frown face, if you will. So if the a term is positive, it's going to look like this. But if the a term is negative, it's going to look like this. And there are a lot of applications for quadratics. So we'll talk more about this on some other videos, but this is just an introduction about quadratics. So a lot of things in the real world end up being quadratics. They end up having a parabolic shape. Some of them would be like a satellite dish. You've got a signal coming in from somewhere out in space, and it hits this parabolic shape and then is reflected through to a point here. So what happens is it hits and then is reflected through that. So signals that come in, they're coming in parallel because they're coming in from so far out. They're hitting on this parabolic shape of a satellite dish and then reflected into this transmitter here, and you get a signal on your TV. Well, this satellite dish is in the form of a parabola, so it's a quadratic. It just in reverse would be like a flashlight head. You know, a flashlight head looks like this. If you've ever looked into a flashlight, you'll notice that there's a bulb in there. And then this shape here is that of a parabola, and it's usually a mirror. So what's happening is the light is being emitted and it's hitting that mirror, and then it's being reflected straight out. And based on how you turn the head and everything, you can diffuse that light so that it's focused, or you can diffuse it so that it's more broad. But when it's in focus, what happens is the light from this bulb hits, and it hits at different angles, and it's this reflected straight out. So this is the property of a parabola. So the flashlight head has a mirror reflective material there, so that the light is coming from the bulb and hitting, and then always reflected straight out. And like I said, you can diffuse that light to make it more broad, or you can make it more focused. But that is the idea of a parabola as well. So here are two real world applications: a satellite dish, a flashlight, and then last but not least is any kind of artillery that doesn't have a motor on it or a GPS or anything like that, but just old artillery that was launched from the ground and would come up, and then due to gravity it would have a height that it reaches. This is where it was launched from, this is where it's coming back to the ground. That's a huge application of quadratics as well. Anyway, so that's a little bit with quadratics. So hopefully you'll search out some other things with quadratics and you'll learn. But just to get you started here, this is an introduction to quadratics. See you later.